So in the last video, you learned how to solve logarithmic equations. And the steps are get all of your logarithmic expressions on one side of the equation and all of your constants on the other side of the equation. Then rewrite the log as an exponential equation. So let's do that here. We have log base 4 of x plus 1 equals log base 4 of x minus 2 plus 1. So what I want to do is I want to start out by moving all of the log expressions to one side of the equation. So I'm going to subtract log base 4 of x minus 2 from both sides. All right, so over here on the right side of the equal sign, I'm canceling those out. And so I end up with log base 4 of x plus 1 minus log base 4 of x minus 2 equals 1. Now I'm going to use log properties to combine. So I wanted to use the quotient property here because I have subtraction. The quotient property says that if I have log base b of m minus log base b of n, that's equal to log base b of m over n. So whichever log is being subtracted, the argument of that log becomes the denominator of the argument of the new log. So this will be log base 4 parentheses x plus 1 over x minus 2 equals 1. And then we want to rewrite as an exponential equation. Remember, if we have b to the x equals y, that's the same as log base b of y equals x. So here, the exponent is going to be 1. The base is 4. So here I have the base of 4. The exponent will be whatever is on the other side of the equal sign. The output of the log is the exponent. So this will be x plus 1 over x minus 2 equals 4 to the first power. Now that's just 4 to the first power is just 4. So I have x plus 1 over x minus 2 equals 4. And now I just have to solve. Now it's a regular equation, and I can solve it by multiplying both sides by x minus 2 in order to clear the fraction. So I'm going to multiply this side by x minus 2, and I'll multiply the right side by x minus 2. So I end up with x plus 1 equals 4. I'm going to go ahead and distribute that. So it will be 4x minus 8. And I'm just trying to solve now. So I'll go ahead and subtract 4x from both sides. I'll go ahead and subtract 1 from both sides. So I end up with negative 3x equals negative 9. Divide by negative 3. And we end up with x equals 3. Now, if I wanted to check, I could go ahead and plug the 3 in. My original was log base 4 of x plus 1 equals log base 4 of x minus 2 plus 1. So I'm going to check by plugging in the 3. I'm going to check x equals 3. So I'll have log base 4 of 3 plus 1 equals log base 4 of 3 minus 2, close parentheses, plus 1. So this gives me log base 4 of 4 equals log base 4 of 1 plus 1. Now we learned in our log properties that log base b of b is just 1. So this is 1. We also learned that log base b of 1 is always equal to 0. So 1 equals 0 plus 1. So that checks out. So we know that 3 is the correct answer. So again, we get all our logs onto one side of the equation, get all the constants on the other side, use log properties to combine into a single logarithm, rewrite in exponential form, and then solve for the variable. If the equation only involves logarithmic terms of the same base and no constant terms, so no constant terms involved, then you can simplify the process by getting a single logarithm on each side of the equation and setting the arguments or the insides to be equal. But this only works if you have no constant terms. In our last example, we did have a constant term, so we could not do that. But here, I could go ahead and combine log base 3 of x plus 9 minus log base 3 of 5 into a single logarithm, log base 3 of x plus 9 over 5, using that quotient property of logarithms, equals log base 3 of x. So remember, the quotient property says that if you have log base b of m minus log base b of n, that's equal to log base b of m over n. All right, now I have the same base here. And because they have the same base, the arguments or the insides have to be equal. So the insides have to be equal. So I'm going to have x plus 9 over 5 equals x. And I want to go ahead and solve that. So I'll start by multiplying both sides by 5. Multiply by 5 here, and that cancels the 5 out. Multiply by 5 over here. So I get x plus 9, because the 5's canceled here, equals 5x. So 9 equals 4x. That's from subtracting an x from both sides. And so 9/4 is my x value. So it simplifies it a lot if you don't have any constants, because then you can just combine the logarithms, set the arguments equal to one another, and solve.